How are you guys? I hope you are doing good. So, guys, as you know, look, till the last class we did about, in real numbers we did what is the meaning of the fundamental theorem of arithmetic. We also learned what is the Euclid's lemma. Okay, and we also understood that by using the Euclid's lemma, how can we got the HCF, right? Okay, so in today's session in the same series we are moving forward, and today's session we are going to learn about the HCF and LCM and their properties, and we'll be also learning the use of the fundamental theorem of arithmetic, right guys? Okay, so please pay attention. I'll say that this class is going to be more important. In this class we are really focusing more towards the question solving part. Okay, so stay tuned and just please pay attention. I'm going to share my screen and let's start it. Okay, yep, fine guys. So okay, slideshow, where are you? Just a sec guys. Yeah, my screen has been shared now and slideshow is also being opened from the beginning. So as I said that the topic that we are going to cover in today's session would be prime factorization. We'll be going to cover LCM and HCF and its properties. At the same time, we will be learning the application of the fundamental theorem of the arithmetic. The theorem we have learned already. In today's session, we are going to focus on the application part more. Okay, let's start. Look at guys. So first of all, what is the meaning of prime factorization? Writing any composite number in the factorization of prime numbers, right? For example, 21 is 3 into 7, right? So 21 has two factors, 3 and 7, and both of them are prime. So writing a number in a factorized form and the factorized factors, that should be prime factors, right? Okay. For example, 36. 36 is 6 into 6. So sir, is 6 into 6 is prime factorization? No. Because you are right, 6 is a factor of 36, but it is not a prime factor now. So when it comes to doing the prime factorization, you need to understand that we have to write the prime numbers, right guys? So look, at the end they wrote 36 equals to 2 into 2 into 3 into 3. Now that is correct. That is a prime factorization. Why? Because 36 is a product of 2 into 2 into 3 into 3, where 2 2 and 3 3, all the numbers are actually there prime factorized numbers. They are the prime numbers, I would say, right? Okay, so guys, this is the method that we use. Okay, using a repeated division method, we'll use that method. We will divide the number by the given by the least prime number by which it is divisible, and then we'll divide again and again and again, and then at the end we'll get the prime factorization of the given number. Okay, for example, I'll give you one example over here. Let's say I need to do the prime factorization of a number, and that say number is 48, right? Okay, so first of all, 48, what is the least multiple of 48? A prime multiple, it's 2, right? If I divide 48 by 2, what I'll get? 24. Then 24 again divisible by 2, so what I'll get? 12. 12 is again divisible by 2, what I'll get? 6. Again divisible by 2. Wow, what I get? 3. Now 3 is not divisible by 2, so after 3 3 is not divisible by 2, so after 2 what is the next prime number? It's 3. Okay, and yeah, we know 3 is divisible by 3, right? So 3 by 3 would be 1. So basically you can write 48 as 2 into 2 into 2 into 2 into 3. So that is the prime factorization of 48, right? It is 2 into 2 into 2 into 2, 4 times 2, and then 1 times 3. Okay, that is prime factorization of 48. And this is how we are going to do for the other numbers as well. Okay, let's move forward then. Okay, perfect. So you need to do the prime factorization of the given numbers, guys. So let's quickly do it. Okay, so 28, first of all, 28 is divisible by 2. Absolutely it is. And then what I'm going to get? I'm going to get 14 divisible by 2. Yep, 7 divisible by 7 only. It's prime number. So then you'll get 1. So 28 is what? It is 2 into 2 into 7. Got that? Okay, एक और बताऊंगा, बाकी would be your homework. Okay, D, I'll tell you 126. Fine. So now 126 you can divide it by 2. Obviously divisible by 2 now. It's a even number. So what you'll get? You will get 63. Now it's not divisible by 2, but it's divisible by 3. Absolutely correct. 21 again divisible by 3, 7, and divisible by 7, and then what you get at the end? You get 7 divided by 7. That's 1, right? So 126 can be written as 2 into 3 into 3 into 7, and that is the prime factorization of 126. Okay, You can also check it. Absolutely, you can check it. You can just multiply these numbers. So 3 into 2, 6, 6 into 3, 18, 18 into 7 is what? Is 80 into 7, 126? Yep, it is correct. That means your prime factorization is absolutely correct, right, guys? Okay, so in the same manner, now you can do for B, C, and E part, and that's going to be your homework, right? Okay, do the homework, and whenever you are getting a doubt in the homework, keep posting on PDF, right? Okay, let's move forward. Now, guys, okay, this is the like that's what we did, and it is mentioned over here. So okay, so it's like yeah, two into yeah, yeah. Okay, you don't get confused over here. Don't get confused over here. Yeah, yeah. This is like यहाँ पे थोड़ा सा ये वो I think there's some error with this PPT. Okay, it's actually 2 power 2 into 7. 2 into 2 into 7. It's 2 power 2 into 7, right? And then 2 into 2 into 2 into 2, 5 times would be 2 power 5 for 32. Okay, it's like that, and that is for 28. Okay, तो वो थोड़ा सा it's wrong. It's not wrong actually. वो typing error है. So let's forget about that. Okay, got it? Okay, so now it's clear to everyone how to do the prime factorization. It's very simple. Let's move forward now. Okay, perfect. So now we are going to discuss about the LCM and HCF. देखो, we have learned how to do the prime factorization. Actually, by prime factorization, we find the LCM and HCF. So now we need to understand that part. But first of all, देखो, I know you. A lot of people already know about it, but still, let me explain to you. Okay, what is the meaning of LCM and HCF? Guys, LCM is least common multiple. Okay, and HCF is highest common factor. So when I'm talking about the least common multiple, what is the meaning of that? That you have two numbers. Okay, you have to find a number which is multiple of both of them, and you need to find the minimum number like that. For example, like what is the least common multiple of 2 and 3? So we need to find a number, okay, which is a multiple of both 2 and 3, and that has to be the minimum number, right? Or you can understand like that, a minimum number which is divisible by both 2 and 3. Minimum number, least number which is divisible by both 2 and 3. That's 6, right? That's absolutely 6. 6 is divisible by both 2 and 3. And it is the least one as well, right? Apart from that, the lesser number from 6, 1, 2, 3, 4, 5, they are not divisible by both 2 and 3, right? Got it? That is called LCM, least common multiple. Okay, so if you read it, they have given that LCM of 10, 15, and 20 is what? A least number that is divisible by 10, 15, and 20. What is the number which is divisible by 10? 10, 20, 30, 40, 50, 60, all of them. Number divisible by 20, 20, 40, 60, 80. And number divisible by 15, 15, 30, 45, 60. So what is the least number that is coming in all of the three? That's 60, right? 60 is divisible by 10. It is divisible by 15. And it is also divisible by 20. Okay. Next thing is your HCF. What is HCF now? HCF is actually highest common factor. What is that? Highest common factor or greatest factor. Factor means क्या होता है देखो? A number which will divide all the given numbers, and you have to find the highest number like that. For an example, 16 and 12. What is the highest common factor? देखो ये तो it's very simple. Highest common factor directly he's saying, right? So what is the factor of 16 and what is the factor of 12? We know that about that, right? Out of these factors, there should be one factor which is common for both of them, and that should be highest as well. That's 4, right? 4 is coming in 16 as well. Okay, 4 4s are 16 and 4 3s are 12. So 4 is a common factor of highest common factor, I would say, of 16 and 12. Okay, fine. But again, now the point is that how to find the LCM and SCF. Sir, this is okay. You told us and we understood, but what would be the actual method? Okay, देखो, repeated division method we are going to use. For an example, you need to find the LCM of 24 and 36. So what you will do? 24, 36, both of them are divisible by 2. Divide them by 2, and we are doing it like simultaneously. Okay, 24 divided by 2, 12. 36 divided by 2, 18, right? Then 12 and 18, both of them are dividing by 2. So 12 divided by 2, 6, 18 divided by 2, 9. Now 6 and 9, we need to find a number, okay, which can divide both of them. And that's 3, right? So 3 will divide both of them. So I'll get 3 2s are 6 and 3 3s are 9. Now 2 and 3 is the remaining at the last. 2 and 3, they are not divisible by any number, right? Okay, so now we'll stop it over here, and what we'll write that the LCM of these two number would be this 2 into this 2 into this 3 and into this 2 and this 3, whatever will remain at the end, we'll also write that part, right? So what is the LCM of 24 and 36? It's gonna be 2 into 2 into 3 into 2 into 3, and that's 72. Okay, and how to find the HCF now? देखो HCF के लिए आप क्या करोगे? Same thing you have to do. Okay, same process you have to follow, but in the HCF now, you will not write this 2 and this 3 at the end. Okay, you just write 2 into 2 into 3. That's it. That's 12 is the SCF, right? So you have to use the repeated division method. In LCM and SCF, both of them, you have to find the number by which both of them are divisible. At the end, you will get that key abhi divisible nahi hai. At that step, you will multiply all of these part with the remaining number. You'll get the HCF. If you multiply all of this part, the column parts, right? What you will get is called the HCF. Okay, got it? Okay. Now guys, I think before going to the other thing, एक काम करते हैं पहले थोड़ा हम ना क्वेश्चन सॉल्व करते हैं, ठीक है? Basic question first of all, let's solve. Let's say I'm asking you to find the LCM and HCF of, find LCM and HCF of, I'll write a question over here. Find LCM and HCF of 48 and 54. Okay, look at this now. So you'll do the prime factorization. In one way, you can find both things. Okay, both of them are divisible by 2. So 2 24 and 2 27, right? Now both of them are divisible by 3. So 3 8s are 24 and 3 9s are 27. Now they are not divisible, right? 8 and 9 are not divisible by any number. Okay, so what is the HCF? HCF would be 2 into 3 only. You just multiply the column element. So 6 is the HCF. What is the LCM? It's gonna be 2 into 3 into 8 into 9. Okay, that's gonna be 144 into 3, right? I think it's 432. Yeah, that's your LCM. Got it? Simple ही तो है. You did the repeated division method, and at the end देखो क्या होगा? You will get a number which is not divisible. Like 8 and 9, they have nothing common in them. Nothing common factor is there, right? At that part, you will stop. You will multiply the column 1 to get the HCF. You will multiply the column 1 with these 8 and 9. Okay, so you'll get the LCM. Okay, got it? Simple है? Okay. Now we need to understand some properties of LCM and HCF. There are some very important properties. We need to understand that. First तो बहुत ही ज़्यादा important है. देखो क्या बोल रहा है. The product of LCM and HCF of any two given natural numbers is equivalent to the product of the given numbers. The product of LCM and HCF is equal to the product of the given numbers, right? So I'll just quickly go forward and I'll just show you this property. We got the LCM and HCF of 40 and 54. HCF was 6 and LCM was 432, right? Look at this now. So what is LCM into HCF? It was 6 into 432. If we solve it, what you'll get 6 2s are 12, 2592, right? Okay. And what was the product of numbers? Product of numbers. Let's do that part as well. Numbers was 48 and 54, right? So 48 into 54, right, guys? So if you solve 48 into 54, what you are going to get? You are going to get 2520 minus 2700 minus 96. Okay, 2592. Not 96. It's gonna be 108. 54 ka double. Yeah. So you can see that HCF into LCM and the product of the number, they are same things. This is really helpful property. While we'll solve the problems, I'll show you how we use it. Okay. Property number 2, guys. Property number 2 says that HCF of co-prime numbers is 1. Therefore, LCM of given co-prime number is equal to the product of the numbers. Very good. It's a very good property actually. Dekho. If there are two numbers which are co-prime means they have no common factors. In that case, their highest common factor is going to be 1. अब आप सोचो, what I just told you that product of numbers is equivalent to HCF into LCM. If you are saying the numbers are co-prime, then what is the HCF? HCF is going to be 1. If HCF is going to be 1, in that case, LCM would be what? Product of numbers. Simple. Okay, so if there are two numbers given to you and they are co-prime numbers, like they have no common factors, in that case, you will not worry. What you will do is that to get the HCF, that's 1. To get the LCM, you just multiply the numbers. You get the LCM, right? For example, यहाँ पे देखो given example is there. What is the LCM of 21 and 22? So just multiply them, 21 into 22. What you get is the LCM. Got it? Next thing, a very, very important one now. How to find the LCM and HCF of fractions? Okay, so look, to get the LCM of fraction, LCM, you are finding LCM, right? So for numerator, we'll find the LCM. For denominator, we'll find the HCF. Okay, like whatever you are finding now, same thing you will find from the numerator, and for denominator you will find this just opposite thing, or just opposite to nahi bolunga because LCF and LCM, they are not opposite, but yeah, here we can take them as opposite, right? So HCF of fraction nikalna hai, if you want to find the HCF of fraction, right? So HCF of numerator divided by LCM of denominator, that's it. For an example, dekho, let's say you have to find the LCM and HCF of 4 by 9 and 6 by 21, right? So first of all, let's say I want to find the HCF. So to get the HCF, what I'll do? I'll find the HCF of the numerators 4 and 6, and I'll find the LCM of what? 9 and 21, right? So what is the highest common factor of 4 and 6? 2, right? Okay. And for this, what I'm going to get? 63. Yep. HCF, LCM is 63, right? For 9 and 21. Fine. That is the HCF of 4 by 9 and 6 by 21. I hope it's clear to everyone. So to get the HCF of numerator divided by LCM of denominator. And to get the LCM of numerator and divided by HCF of denominator. Okay? Got it? Whatever you are finding will come in the numerator part. That's it. Fine. Probably number 3rd done. Yeah, please note it down as the important part. Okay. Oh, wait a second. Wait. Yeah. There's something which is actually really important. So guys, please pay attention on this. Okay. This part. Yeah. Let's move forward now. 4th property. HCF of any two or more numbers is never greater than any of the given number. Yeah, obviously baat hai. What is HCF? Highest common factor. You are finding factor of a number. How it can be more than both the numbers? It's not possible, right? Factor number से बड़ा कैसे हो सकता है? Not possible ना? Okay. So and LCM क्या होता है? LCM of any two or more number is never smaller than, yeah, LCM is least common multiple. We are finding a number. Okay. For this particular, this is the LCM, right? This is the LCM. Yeah, if this is the LCM and these are the two numbers, right? So these two numbers actually are dividing this number, right? These two numbers are multiple of this. Up iske the multiple of a number. How the multiple of a number can be more than the number itself? Not possible, right? So LCM of these two numbers cannot be more than the number itself, right? Okay. So LCM is always more. Okay. And HCF is always lesser. Right? So, or that's what they wrote now. HCF cannot be greater than the numbers and LCM cannot be smaller than the numbers. Got it? 4 and 5 property, both of them are done. अच्छा example ले लो. It's HCF of 4 and 8 क्या है? 4 है. So HCF is not more than the numbers, right? So yeah, it's not more than 4 and 8. It's 4 exactly, right? And what is the LCM of these numbers? It's 8. So LCM cannot be smaller than the numbers. Okay. So look, 8 and 8 is not smaller than any of them. 8 is more than 4 as well as it's not smaller than 8. It is equal to 8. That's a different thing, right? But it's not smaller. Got it? So फिर question करें. 8 and 9 are two co-prime numbers. Using these numbers, verify LCM of co-prime number equal to product of. देखो इसको verify करना है. We need to find the LCM, right? So LCM कैसे निकालते हैं हमने बोला अभी. 8 and 9 will write. This is not divisible now. So we'll write the one only. So option ही नहीं है. So what is the LCM? It's gonna be 8 into 9 and that's 72, right? Okay. So LCM is equal to product of co-prime. I mean, we need to verify that, right? So what is the product of the numbers? Product of numbers is what? 8 into 9 and that's 72. You can see that the product and SCF, they are equal to each other, right? As 8 and 9 are co-prime, we can write over here as 8 and 9 are co-prime. So you can see that over here what happened, that their LCM and their product was same. So product of two numbers was same as their LCM because these two numbers were co-prime. Got it? Okay, fine. ठीक है, हो गया तो हमारा. Yeah, next question is, guys, HCF of two numbers is given to you, you have to find the LCM. So what we just learned that HCF into LCM equal to product of two numbers, right? That was the first property. Two given numbers, I'll write. So what is HCF? It is 128 LCM, I don't know. What is the product? 1152 into 111664, right, guys? So what is gonna be the LCM? It's gonna be 1152 into 1664 divided by 128, right? Divide करो. So देखो ये आएगा अपने पास 9 times, right? Okay. So 1664 into 9. That's gonna be just a second. 9 4 36. So 6 3. I think it is 14976. Yeah. Okay, that's the calculation and just check it. Okay, so 1664 into 9 added, and what we got is that 14976. Okay, हो जाएगा, not a problem. Got it? Let's move. This is how you solve the question. Okay, this is how you use the property that HCF into LCM equal to product of the two given numbers. Okay, next question, guys. This is a good question. Now find the greatest number of 6 digits, exactly divisible by 24, 15 and 36. So we have to find a number actually. Okay, and we have to find a number of 6 digit, and this number should be exactly divisible by 24, 15 and 36. How to solve these kind of questions? So please now everyone pay attention on it. Okay, अच्छा पहले तो एक बात है कि what is actually the greatest number of 6 digit? Greatest number of 6 digit is what? That is 99999. This is the greatest number of 6 digits. If I add 1 now, it would become a number of 7 digit, right? Greatest number of 6 digit we got. What you are asking me is that, but this is not we have to find. We have to find a number of 6 digits absolutely, but that should be divisible by both of them, all of them, right? Okay. So if this number is divisible by all of them, for that we need to find the LCM of the numbers first of all, right? So what is the LCM of 24, 15 and 36? Let's see that part first of all. So it's gonna be 20 LCM, right? Least common multiple. We'll divide it by 3. All of them are divisible by 3, right? So 3 से divide करके कितना आएगा देखो, 8, 24, 5 and 12, right, guys? Okay, now 8 and 12 is divisible by 2, so we'll divide it by 2 now. So 2 divide करके कितना आएगा, 4 2 is 8, 5 is almost on its plates. जब तक divide होगा तो divide करेंगे. Okay, then again you can divide it by 2, so you'll get 2, 5 and 3. Now it's not divisible, right? Okay, so what is going to be the LCM? The LCM is going to be 3 into 2 into 2 into the remaining 3, 2, 5 into 3, right, guys? So that's going to be it's 360, right? So the LCM is, we are getting the LCM as 360. Okay, now just pay attention on this thing. We need to find a number which is of 6 digits and which is divisible by 24, 15 and 36. A number which is divisible by 24, 15 and 36 is a number which is divisible by 360. ठीक है, अब एक ऐसे हो आप ना क्वेश्चन वाला दिमाग अपना चेंज करो. You need to think like that we need to find a number of 6 digits, greatest number which is divisible by 360. ठीक है, अब देखो अच्छा एक बात बताओ मेरे, जैसे मैं आपसे बोलता हूँ कि find the number nearest to 10 which is divisible by 3. So what you will do, देखो सिंपल है, you will divide 10 by 3, remainder आएगा 1. So you will say if from 10 if I subtract 1, what I'll get? 9. 9 is the greatest number, or 9 is the 9 सबसे 9 is the nearest number to 10 which is divisible by 3. Got it? Same way we are going to do over here. So what we are going to do is that we are going to divide this number by 360, right? So if, just second, just slide नहीं है पीछे. Okay, if 6 times 9 is divided by 360, then what is the remainder? What is the remainder, guys? So कितना आएगा remainder बताओ, यहाँ पे solve करते हैं. देखो 360 divided by 999,999. Okay, so 360 2s are 720. You get 9 and 7 and 2, and then one more 9. Okay, okay, 2 more 9 would be there. Fine, fine, fine. Then abhi 8, I think आ जाएगा 8 ना. So 8 0, 8 6 are 48. Oh no, 7 times आएगा. Sorry guys. 7 0, so 7 6 are 42. 2 25, right? So it's gonna be 972. Okay, 279 again. तो ये वाला 9 यूज कर लिया, ये 9 फिर से यूज करेंगे तो फिर से 7 आएगा, फिर से 2520 आएगा, एंड फिर से 279 आएगा, एंड फिर से 7 करेंगे तो फिर से 2520 आएगा, और फिर से 279 आएगा, राइट? सो गाइस अल्टीमेटली the remainder what we are getting is 279. So the number which is nearest to this number and which is divisible by 360 क्या होगा? अब इस नंबर में से देखो सिंपल है ना यार, if you are subtracting the remainder, the number that you are going to get would be a number which is divisible by 360, right? So the greatest number of 6 digit, greatest number of 6 digit, okay, divisible by 24 and 15 and 36 would be what? It would be 99999 minus 279, right? That's gonna be 0, 7 and 2 9, and it's 7 and then 999. So it's 999,720, right? Got the process? First of all, what I did, guys, that I got the LCM of the number 24, 15, and 36, and that was 320, 360, sorry. Then from the greatest number, I just seen that what is the remainder if I'm dividing the greatest number of 6 digits by 360. I got the remainder is 279. I subtracted 279 from 6 times 9, right? So I'm getting 6 times 9, 720. Now this is a number which is divisible by 360. And if this number is divisible by 360, it is divisible by all 24, 15, and 36 as well. And it is the greatest one, right? Because this was the nearest one, which was divisible by 360. Got it? Okay, let's move forward. Yeah, guys. So now we are moving forward towards the application of fundamental theorem. As I told you in the last class that, a fundamental theorem actually says that we can, write any composite number as a product of 2 or 3 or more prime numbers, right? That's our fundamental theorem. We just need to see the question based on it now. Okay. So look. There's a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and the same time in the same direction. After how many minutes they will meet again at the starting point? Guys, if you remember, I told you the last like same kind of question in the last slide as well. In the last slide, sorry, last class as well. Okay, दो लोग थे वहां भी. They were on a car one and car two was there, I think. Track पे थे वो लोग, right? So we just need to find the LCM over here, right? Okay, so you need to find the LCM of 12 and 18, right, guys? So you'll get 12, 18. Oh, sorry. 18 का 1 कुछ ज्यादा बड़ा हो गया. Okay, let me rub it just a second. So we need to find, guys, LCM of 12 and 18, right? So we'll get 12 comma 18 is divisible by 2 first of all. You'll get 6 and 9, it is divisible by 3 now. 3 2s are and 3 3s are. So now what is the LCM? It's gonna be 2 into 3 into 2 into 3, right? So it's 36, right? So after 36 minutes, they will again reach, okay, again meet, or when they will meet, Sonia will complete 2 cycles because obviously, na, one round she completed in 18 minutes, so she will complete 2 and Ravi will complete 3, right? उसके बाद they will meet on this point again, on the starting point, right? Got it? Simple question tha. We have already discussed this kind of earlier in the last slide, okay? Yeah, 36 is correct answer. So guys, yep, now this is your homework questions. You need to find the HCF of the numbers 12, 25. ये एक बार मैं करवा देता हूँ आप लोगों को because this was something again. HCF find out करना है. There are 4 numbers. So how to do that? As I told you, HCF of numerator divided by LCM of denominator, right? Give it a try quickly and tell me the answer. I'm giving you 1 minute, guys. Give it a try. I'll just bring some water for me. Just give it a try. Okay, so let's do it then. We need to find the HCF of the numerator and the LCM of denominator, right guys? So what is the HCF of 12, 9, 18 and 21, right? 18 and 21. And in the denominator, you have to write what? LCM of the denominators, and that is 25, 10, 35 and 40. ठीक है? तो पहले बात करते हैं हाईएस्ट कॉमन फैक्टर फाइंड आउट करना है 12, 9, 18, 21 का. यहाँ पे आ जाओ. 12, 9, 18, 21 डिवाइडेड बाय 3. ओके, सो कितना आएगा? एवरीथिंग इज डिविजिबल बाय 3, राइट? सो 3 4s are 12, 3 3s are 9, 3 6s are 18 and 3 7s are. अभी nothing is there. We cannot find the number 9 out because 4 3 6 7 there is nothing common in them, right? So what is the HCF? It's 3 only. What is the LCM? Let's see that. 25, 10, 35 and 40. Okay, first of all the numbers are divisible by 5. Divide by 5 kar do. 5 5 are 25, 5 2s are 10, 5 7 are 35 and 5 8s are 40. Now 2s are divisible. Any two numbers should be there that are divisible. We'll continue the process. 5, 1, 7 and 4. Abhi we'll get nothing, right? So what is the LCM in that case? The LCM is gonna be, I'll write over here directly. Okay, 2 into 5 into 5 into 7 into 4, right? So it's gonna be 100 into 1400, right? But 5 into 5 25, 25 into 2 50, 50 into 4 200, 200 into 7, correct? Okay, so guys, the HCF of this complete 4 fractions is gonna be 3 by 1400, right? Okay, next question is that given that HCF of these two number is 9, then find the LCM, right? So which property we are going to use for question number 2? For question number 2, guys, we are going to use that LCM into HCF. Okay, that's gonna be product of the numbers. So HCF is 9, LCM we don't know, and product of the number it was 306 into 657, right? Now I know you are quite sharp with the calculations, so you'll get the answer yourself. Okay, guys? Okay, so you just multiply 306, or why to multiply? Just divide it by 9 first of all, right? So 9 3s are 27, 3 and 9 for 36. So it would be, I'm writing the answer. Okay, so 9 3s are 27 and 3 bach jayega, 9 4s are 36 and 657, right? So 34 into 657, yeah, now I'll do yourself. That's gonna be your answer. Okay, question number 2. Got it? Fine. Question number 3, ek to homework le lo at least. Okay, this is gonna be your homework question. Fine, you do this question in the homework, and if you have a doubt, keep me posting on the batch discussion forum. Okay, that's it from today's session, guys. Bye bye everyone, take care, see you in the next class. Bye bye, enjoy, bye bye, have a nice day, guys. Bye bye.